Hi, my name is Sam Dhanashekaran and welcome to this video lesson. So in this lesson, let's take a look at how does a computer work. How does a computer function? Okay, so let's take a very high level overview. We all saw that a computer contains a system unit and input-output devices. Please check the video What is a Computer in this series if you haven't already. We also saw that there are three main components in the system unit called CPU or processor, RAM or memory, and hard disk drive. One additional note is in any computer, the CPU and RAM will generally be in a single circuit board called motherboard. This motherboard will be inside the system unit. Actually, I am itching towards teaching you computer hardware, but let me stay out of it so that I can quickly get to cloud computing. So what happens when you power on the computer? It's just a machine. And actually, nothing should happen and nothing will happen. So, how did the computer manufacturers tackle this? First, the motherboard manufacturers installed a chip that contains a piece of software code in it permanently. This chip is made in such a way that once you engrave that software code into the chip while manufacturing, it resides in there permanently. It can never be modified. We can say that it is read-only because it can never be modified or deleted. So because of that, that chip is referred as read-only memory, also known as ROM. The piece of software code they engrave into it is called BIOS, which is an acronym for Basic Input-Output System. Again, I'm trying to keep things very simple. There are lots of variations of this ROM, from PROM, which is programmable ROM, to EEPROM, which is electrically erasable and programmable ROM. So those are out of scope for this video series. Now, coming back to powering on. When you power on a computer, you notice that it starts, takes few seconds or minutes to load some programs in the background and presents you with a login screen. This process is called booting. So let's go over the boot sequence. As soon as a computer is powered on, the CPU looks at the ROM and finds the BIOS, which is the piece of code stored in it. It then loads that into the memory, which is RAM, and executes it. The BIOS software code contains a section called POST, which is Power On Self-Test. This gets executed first. As the name would imply, this routine or this section of the software performs a self-test of all the components connected to the processor. Like it scans the whole RAM just to check if they are good. It also checks the hard disk or any storage device connected to see if they can be accessible. It also checks for any other input-output devices like keyboard, mouse, etc. A lot of things have changed, but this is the concept. Once every device has been successfully scanned, then it looks for the bootable device. Generally, the hard disk is the bootable device. Now, what is a bootable device? A bootable device is a device which contains the operating system. In your PC or laptop, it will be generally your hard disk, and the operating system would be Windows. If you are using a Mac laptop or Mac desktop, then your operating system would be the Mac OS. The point is, the hard disk will be your bootable device and it will contain the operating system. For advanced students, please note that I am ignoring solid state devices as I do not want to get into teaching hardware in detail in this video series. So now, what is an operating system? Let me just call the computer as a hardware, and it needs software which are sets of instructions to function. Now, a hardware can be made by multiple vendors with entirely different type of processors and architecture. So if we were to write a code for each of these hardware, then we need to write them in a way that these hardware can understand, or we need to write them in a language understood by these hardware. So if I have to write a piece of code for a hardware, I need to write it using a set of instructions understood by that particular machine. And if I want that piece of program to run on a different hardware, then I might have to rewrite it using the set of instructions understood by that hardware. And these set of instructions are very difficult to understand and are very low level in nature. These are called machine languages and assembly languages in general. Okay, so with the data science and artificial intelligence, there is a whole different concept of machine languages into picture. But originally, okay, the machine languages are just binary languages used to interact with the hardware. So I'm referring that. Okay, I'm talking like 20, 30 years ago. Okay, let's not confuse this with the machine languages that the data scientists refer. Like I said, I am combining a lot of things to move as fast as I can get to cloud. So at the same time, I do not want to skip any important information in between. To standardize this, operating systems came into picture. They said, hey, I'll take care of interacting with the hardware. I'll take care of managing the hardware. You just write your code to interact with me. And wherever I am, no matter what kind of hardware it is, I will run your code. Again, I'm kind of simplifying it, but I hope you get the gist of it. So for example, I will install operating system from Microsoft and let's call it Windows 10, which supports Intel-based processor on the hardware made using Intel-based processor. For another hardware which is based on AMD processor, I may install Windows operating system which supports that hardware. Once I have Windows, same version of Windows running on both computers, let's just call Windows 10, now I'm free to write a code which will only interact with Windows. And Windows will take care of the communications between the hardware and the operating system. So If I write an application containing software codes, all I need to do is to use the set of instructions supported by the operating system. It will run on any machine where the same operating system is in. Generally, there are a lot of programming languages such as Visual Basic, C, Java, Python, etc. available in the market. These are called high-level languages which allow you to write a piece of code very easily as opposed to the low-level machine languages. Again, I'm referring to the low-level machine languages, not data science. Using these high-level languages, you can write your programs. To do that, generally we install the programming language software such as C++ in this case on the operating system. Then we write code using that language. We compile it, create executable programs, and then run them as individual applications on the computer. Point is, yes, we need an operating system. So far, I have introduced CPU, which is a compute resource, RAM, which is memory resource, hard drive, which is storage resource, operating system to you. So these are fundamental aspects of any IT architecture. In cloud computing, these are very important factors in determining the cost of your subscription. Okay, thank you for watching.